we will talk about the problem related with the decay constant or probability of disintegrations. So let's do that with the first problem. That is, what is the decay constant of vanadium, which has a half-life equal to 3.74 minutes. I mean, we are given a questions or a problem, and that problem they have given us the decay. They are asking about to calculate the decay constant, the value of the decay constant, and we are given a particular element with a half-life is equal to 3.74 minutes. So how to solve this problem? You know that for decay constant we have the formula that is lambda is equal to 0.693 divided by the half-life. So how we have to deal with this problem? Let's come to all the solutions. That is we have lambda is equal to 0.693 just as we have in the formula, and instead of the half-life you have to put the values. I mean, here we have the values for the half-life, which is equal to 3.74 minutes. So you just put here the value of 3.74 minutes. You know that the SI units for time is second. So what do you have to do? We have to change minutes into second. So for this, what do we have to do? We have to multiply this whole relation by 1 minute divided by 60 second. I mean, this is just the relations, and are to have the values in second. Why in second? Because second is the units for time and system international. That's why we should have this value in second. So you do the calculations, minute will cancel with minute, we will left with the second. You just do the simplification. At the end we will have the values for the decay constant, which is equal to 3.09 and 10 raised to power minus 3 per second. So this is the solution for this particular problem. We remember we have to change the problem. In some of the problem you will be given the decay constant, the value of a decay constant, just like we have calculated in this problem, and you will be asked to find out the value of half-life. So what you have to do, you just have this formula, and this formula I mean, just like we have this formula, you just have to put the values of the decay constant, and you will simply do the calculation to find out the value of the half-life. So it's very simple. You just have to have a clear look on the problem what they are asking. The second problem, that is, they're asking what is the decay constant for chromium, which has a half-life equal to 27.7 days. So how you find the solutions? Again, we are given the time is the half-life is 27.7 days. So first of all, what do you have to do? You have to convert this given value, that is 27.7 days, and to second. So first you have to convert that in hour, then into minutes, and then into seconds, and you just then you just need to put the values in the formula. That is that we have here. The formula is lambda is equal to 0.693 divided by it's the given half-life 27.7 days, and then we have how to convert this 27.7 days into second. We have to multiply it by 1 over 86,400 second. I mean, if we want to convert this whole relations into second, so we have to multiply this relations by 1 over 87,400 second. So what you will get, you do these simple calculations, and after that you will get your required value, that is equal to 2.89 and 10 raised to power minus 7 per second. Again, I'm telling you, we can switch the problem. We can I mean, it's possible that they might ask you to calculate the half-life, and in that particular case they will given you the value for the decay constants. They can reverse the problem. Another problem is what is the decay constant for radium, which has a half-life equal to 1622 years. So, I mean, it's a bit difficult. We have changes in half-life. I mean, in first problem, the half-life was given in minutes, and second problem it was in days, and third problem it is given in years. So, what do you have to do? The difficult task is you have to convert minutes, days, and years into seconds. I mean, this is the most tedious task. If you know this track, just like I mean you people have under your matriculations and your intermediate classes, that you have to switch between the units. You have to switch the multiple of unit, that is, you know, the tracks how to change seconds and to minutes and to hours, days, and even to weeks or years. So what do you have to do? Again, you have to proceed like previous one. You have the formula, and that formula you have to put the exact values, and after that you should know how to convert years into days, and then into seconds. So you know that in 1 years we have 365 days, and in 1 day we have 86,400 seconds. So what you have to do? First you have to multiply this relation by 1 over 86,400. Then you have to multiply by 1 over 365 days. Why is? Because you know that in 1 day we have 86,400 seconds, and at the same time we say that in 1 year we have 365 days. So this is why we have put this extra terminologies in order to convert these years into seconds. So you do the calculations. So after these calculations, you will get the values. That is, you will find the answer for the decay constant, which is equal to 1.55 10 raised to power minus 11 per second. So this is the way, this is the simple way how you deal with the decay constant problems. And let me say again, we can change, we can switch the problem. We can ask you about to calculate the half-life, while in that particular case uh, we will give you the value for the decay constant. So what you have to do? You have to specialize and solving problem, especially related with the decay. Sometime we will not use the term decay constant. We may ask you to find out the probability of disintegration. So it's the same for the current course. Probability of disintegration or decay constant, I mean, almost the same. Hope you understand problem. I think it's okay for now. You have to focus on